Okay, is the question clear? Find the velocity VA, and find velocity when the ball is going inside the basket. So part one. Okay, we know something about the trajectory. We know that the ball passes through the basket at B, which is at coordinates 10, 3. So what I'm going to do is I'm going to use that fact. Here the coordinate system is chosen to be here. This is 0, 0. Okay. So what I'm going to do is I'm going to write the position as a function of time. So let's write the position. This is a formula which I had written down earlier. X equals VA cosine theta t, and y is VA sine theta t minus half g t squared. And of course I forgot to put x0 and then y0. Okay. Now because my origin is right the point at which the ball is launched, x0 is 0 and y0 is 0. Now you could potentially take the origin to be here. If you take the origin to be here, then obviously your x0 is going to be 0, but y0 would be 1.5. That's also fine. That'll give you the same answer. It doesn't matter where you choose the origin. Okay. Okay, so let me sub in x equals VA, which is an unknown, cosine of 30 degrees times t, which is also the unknown. In this case, I'm going to try to put x equals 10 because I know that the ball eventually goes through the basket. And I'm going to write the y coordinate to be, well, the y coordinate is measured from here, right? So this is the y. So it's going to be 3 minus 1.5. So 1.5 equals VA sine 30 degrees t minus half. Gravity is 9.81, and I'll give this to you. It's a constant. So those are my two equations. And there are two equations. Yeah, question? No, because my origin is here. Because the origin is here, I need to measure relative to this. So this is 1.5. Two equations and two unknowns, right? VA and T. And so we know that if we have two equations and two unknowns, we can solve for those two unknowns. What I would do is I would find T. T is 10 divided by VA cosine 30. Put it in this expression. That prime. Same expression. And so you'll have one equation, one unknown, and solve for VA. So if you do this, you get VA. Let me write this 1 and 2. So from 1 and 2, VA comes out to be 12.36 meters per second. So that's our answer. And then the second question asks you to find the velocity when the ball is about to hit the basket. And by the way, you can also solve for t. So t comes out to be 0.9339 seconds. Okay, it's not asked, but you can find that because you're solving for both those unknowns. So for part 2, we need to find the velocity when passing through the basket. So the formula for velocity as a function of time is Vx is V0 cosine, VA cosine theta, and Vy is VA sine theta minus GT. Okay, so we need to find the velocity at time t equals 0.9339, because we know that in that much time, 0.9339, the ball is going to be at B. So we sub in VA equals 12.36, theta equals 30 degrees, t equals 0.9339, and g equals 9.81. And we can solve for Vx. It's 10.7 meters per second, and Vy is minus 2.97 meters per second. So the negative indicates that the ball is traveling downwards, because the convention is upwards is positive, which is right? When it enters the basket, it has to have a downward velocity. And so if you're asked to find the velocity at B, we are asked to find the magnitude, which is Vx squared plus Vy squared. Answer is 11.1 meters per second. Okay, any questions on this? Questions? Okay, so here's a question I want you to solve and poll your answers using iClicker. The ball is kicked from point A with an initial velocity of 10 meters per second. Determine the range R. So they've not shown the range, but this is the range R. And the speed when the ball strikes the ground. Let's ignore the second part. Okay. Okay. So I want you to solve for range R and poll your answers. Okay. You can take gravity to be 9.81. C. Okay. We use the fact that we know the y coordinate of point C. It's basically the same as that of A. So I'm going to write the equation for the y coordinate. Y equals y0 plus v0 sine theta t minus half g t square. Y equals y0 equals 0. This is my origin, 0 comma 0, right? So I can write 0 equals 0 plus the velocity is 10 sine 30 degrees times t minus half 9.81 t square. So this is sine 30 is half, so 0 equals 5 t minus 4.9 4.9 t square. So t equals 5 divided by 4.9. It's 1.02 seconds. And so once we get that, we can then write the equation for the range, which is x equals x0 plus v0 cosine theta t. So x, which is the range, is 0, x0 is 0, plus 10 cosine of 30 degrees times the time, which is 1.02. So 10 times cosine 30 degrees, so 8.83. So the range is 8.83 meters. Okay, clear? Is that clear? Any questions? Okay, 883. 8.84 is right, 8.83, 8.82. Okay. Did not count something?
You know how to put the decimal.
Okay, so find the horizontal velocity if the ball just clears the wall. Okay, by that, this is the 3 feet wall. And then find the horizontal distance s when the ball hits the ground. So this is a very similar question as before. If the ball has to clear the wall, the 3 feet wall, then we can use that information to find the velocity with which the ball is hit. Okay, and this problem is well, it's very similar to the previous one, but you have to be very careful about how you set the coordinate field. So in this case, the velocity is actually pointing in the negative x direction. So we'll just solve it with all that convention in, so that you don't make an error. So let's solve for part 1. Find the horizontal velocity. So again, I'm going to set up 2 equations. One equation for the height and one equation for the distance, 21 feet, and then use that to find the time and velocity, and then I can use that to find the distance s. So let's set up the equation for distance. X equals x0 plus v0 cosine theta t, and y equals y0 plus v0 sine theta t minus half gt square. Okay, so let's take the first expression and try to sub in the values for x, x0, and so on. So before you start doing that, choose a coordinate frame. In this case, I chose the coordinate frame to be as the one shown there. Okay? X is to the right and it's fixed at the base. So x is the distance of point B. So that's going to be minus 21 because it's to the left. My origin is, convention is positive, is to the right. X0 is this point. Well, it's the x position of this point really, so that's 0. V0 is the velocity with which the ball is launched, which is unknown, VA. Okay, what is cosine theta? What's theta? Are you sure? It's 180 because if you launch the ball like this, the angle make with the horizontal is 180 degrees, right? So if you do not put 180, if you put 0, you'll see that your answers, there'll be something funny about the sign. So if you want to be really correct, then you want to put 180. So for example, if you put 0, you'll get a negative time basically. That's what it'll mean. So just be careful. So this gives me minus 21 equals cosine of 180 is negative 1. So this is essentially VA times T. Okay, and then let's take this expression and then sub in the values for y, y0, and so on. Y is the distance of B from the y-axis, along the y-axis from the origin, so that's 3, and it's positive because upwards. Y0 is the initial position of the ball at A, so it's going to be 7.5, and it's positive upward because it's upwards. And then VA is a unknown. Sine of, well, we got to put the same angle, 180 degrees. T minus half. So in this case, gravity is in feet. What's that?
Is there no y?
There is. This is y naught.
I mean, for the velocity.
Well, you're going to get 0.
Oh, I'm going to get 0. Yeah, that's fine. This is 0. Minus the gravity is 32.2, and then t squared. So I'll give you gravity. Don't worry about it. You don't have to remember 32.2, but 32.2 is the value for gravity in foot-pound system. Okay, so from this, I get minus 4.5 equals 16.1 t squared, the negative sign, so I can solve for t. It's 0.53 seconds. Let's call this 1. So what I can do now is put t equals 0.53 in 1. I get 21 equals 0.53 times VA, and from this I can solve for VA. It's 39.6 feet per second. So that's my answer for part 1. Okay, is that clear? Now let's solve for part 2, which is I need to find S. Okay. So this is sort of similar to the problem you solved, which is I know the position of C, the y-coordinate of C. It's basically the same height as my origin, right? So from there I'll find the time, and once I know the time, I can find S. So I'll use the same expression I wrote down. So I need to write the equation for y, which is same as this. So from 2, where 2 I just showed there, I'll put y equals 0, y0 equals 0, because the position of C is what? 0, comma x. My bad. X is 21 plus S, and the y coordinate is 0, right? So the y is 0, and I put that in equation 2 to get 0 equals 0 plus, I know VA, which is 39.6 sine of 180 t minus half 32.2 t square. Something is not right. I get 0. What's wrong?
You start at -21, right?
Yeah, so this is not right. 7.5. Okay, so this is 0. And so I can solve for time from this expression, t equals 0.684 . Okay, the last thing I need to do is I need to sub this in. I'll call this equation 3. I need to use a third equation. From 3 I can write x, which is 21 plus s. That's the range, that's the distance of C from A, equals the initial x, which is the x position of A, which is 0, plus VA 39.6 cosine of 180 times t, which is 0.684. I'm doing a mistake here. I need to put minus 21 plus s because the position is minus 21 plus s comma 0. Okay, so in that equation, the equation I wrote here, the only unknown is s. If you solve this for s, it comes out to be 7.35 feet.